Welcome back to the nitrogen cycle. We've already talked about it a little bit, but here we're going to focus on kind of what does it look like, right? So we've got some of the details, but here we want to focus on what is the visual for nitrogen cycle. So a couple reminders. We know that the nitrogen cycle is interacting with all four spheres, right? We've got it down here in the ground, in the geosphere, got it in the trees and the animals, the biosphere. We also have it in the hydrosphere, in clouds and water. But the one we want to focus on for starters is the atmosphere, right? We said 78% of the atmosphere is nitrogen. So as we look at our picture for nitrogen cycle, let's make a note of that up here at the top. So 78% of the atmosphere is N2, nitrogen gas. Right? That's an important fact that we want to know. So 78% of the atmosphere is N2 or nitrogen gas. And so how does that nitrogen gas get into living things, get into water, get into the ground? So there's a couple different ways that nature allows nitrogen gas to get into the other spheres. The one we're going to focus on is with these little raindrops right here. Okay, one of the main ways that nitrogen gets into the ground, it sounds silly, but simply rides a raindrop down and infiltrates into the soil. So a raindrop collects that nitrogen gas and works its way down into the soil. So from here, that gives us N2 or nitrogen gas inside the soil. But I know that these plants can't take in nitrogen gas, right? Can't absorb, just like people, we can absorb N2. So they have to obtain it another way. And that's where our little BFFs come in, right? These guys. There's a bunch of bacterias down here in our picture. And so remember, the BFF of the nitrogen cycle is that bacteria. Okay? And so what we got going on here is this little bacteria guy. He sees that N2 and he's like, hey, N2, come on over. And the N2, what he does is he rearranges that molecular structure, joins it with some hydrogen, and creates something known as NH3, which is ammonia. And you might remember from the video how we kind of feel about ammonia. Hopefully you have this in your head. Ammonia, bad, right? We don't want ammonia. Plants are not able to absorb that ammonia. That doesn't work. Okay? Plants don't do anything with ammonia. So thankfully, there's another bacteria. So we got this kind of yellow, crazy looking guy down here. There's another bacteria, and its job is then to take that ammonia, do a little work with it, rearrange it, and make it into something known as NO3. Those are our nitrates. And hopefully you remember what we say about nitrates. Nitrates, good. So ammonia, bad, sad face. Nitrates, good. Okay? So now that we have the good nitrogen happening in the soil, that's what the plants can absorb. So we're going to put an arrow right from those nitrates back up to the plants. We kind of went full circle. We started out with the nitrogen gas in the atmosphere. It infiltrated down into the soil with the help of those raindrops. Then our BFFs took over, right? Converted it into ammonia, converted it into nitrates, and now plants are ready to absorb that. So nitrates are what plants and people have inside them. So I'm just going to make a little note here. Nitrates. Maybe that wasn't the best color. Nitrates. So nitrates are stored inside of the plant. Okay, now again, humans, we can't breathe in nitrates or nitrogen gas. We can't absorb nitrates through the roots. So we're kind of like this cow right here. Cow or human, that's kind of like us, right? We have to get our nitrates another way. We have to eat them. So by consuming or eating those nitrates, that's how we get the food that we need. Now we haven't quite gone full circle yet, right? We've got the atmosphere and into gas, got the geosphere, nitrates and ammonia, got the biosphere, nitrates in the plants and animals. Those nitrates can also seep into the groundwater any old way. But how do we get back to the atmosphere, right? We have it coming out, but not going in. Here is our last little bacteria friend. Okay, one more converter bacteria, and its job is to convert nitrates or ammonia, whatever it is, back into N2. Convert into N2, which is the gas. So there is a third type of bacteria that converts those nitrates or ammonia back into gas, which then releases it back to the atmosphere. So now we've kind of gone full circle. And that's definitely a complicated picture, right? We don't have any clear names. We just have kind of a general overview of how it works. So big picture, we want to think about nitrogen gas in the atmosphere, gets into the geosphere and is converted by bacteria into ammonia bad, nitrates good, can also be converted back into gas to be released to the atmosphere. Nitrates are what's good for plants. Plants absorb those nitrates in, and then humans or animals can get those nitrates from eating. So that's kind of our process happening within the nitrogen cycle. And it doesn't matter if the bacteria converts nitrates first or ammonia first. It just is important to know there's bacteria there that can convert to any one of those three forms. So now that we have an idea of how the nitrogen cycle works, we're going to focus on the human impact. Right? What impact do humans have on the location of nitrogen and the balance of nitrogen within all the spheres? Right now we know that nitrogen is mostly in the atmosphere, right? 78% is in the atmosphere. But what we want to think about is, again, what are we doing? And the biggest impact we have is this right here. Allowing excess nitrates to get into the hydrosphere. And excess nitrates are typically found in nature in the following forms. Waste. Here we have our animal waste. Fertilizer, which can be related to that waste or a little bit different, or human waste, known as sewage. And so when we have excess nitrates in those forms, simple things like rain and runoff can push it down into the hydrosphere. So when that happens, here you can see we have an NO3, a nitrate, in the water. We can get too much. And what happens is we know that nitrates are basically plant food. And so we have aquatic plants like algae that eat or consume those nitrates and essentially grow, right? They are impacted by becoming more and more abundant with more and more food. Well, eventually those algae eat and eat and eat, causing the nitrates to dissipate, which is good. However, we now have an abundance of algae. That's where, again, our little BFF bacteria comes in. Okay, what the bacteria do is they start to consume the algae. And as they eat that algae, they breathe in and out just like we do. They are living things, and so they're actually breathing in oxygen. And so when I have more bacteria, what I start to notice is a lack of oxygen. They're breathing in that oxygen to use, depleting it, creating a lack of oxygen from that water environment. And so over time, as that cycle continues, algae eat the nitrates, bacteria eat the algae, that oxygen level drops lower and lower, and what I end up with here is that dead zone. right? A place that lacks oxygen, enough so that aquatic life is struggling to survive. And we call that eutrophication, right? When too much nitrogen is added to a water environment, that leads to the loss or lack of oxygen, and creating that zone not suitable for aquatic things. So again, human impact, biggest impact that we have is creating that imbalance of nitrogen, allowing excess nitrates to run into the hydrosphere, causing those chains of events to create that dead zone. So you should have a full, little bit chaotic picture of 1, how the nitrogen cycle works, and 2, how the human impact creates those dead zones.